Hello and welcome to SudoKanard. This is another excerpt of the instruction booklet for the holiday special Sudoku contest held over on the world-class puzzles from the Netherlands. And this is a very weird rule set called Weiqi. This was invented by Chinese authors for some previous World Sudoku Championship, and I didn't take part in that championship. And when I saw the puzzle afterwards, I did not dare touch it. But I already solved this example puzzle, and I found it to be quite difficult. So the special rule here is that, well, let me just select this. Yes, like this. When you have such a black dot here overlapping 4 cells, it means that those 4 cells must sum to more than 19, that is at least 20. On the other hand, when you have such a white dot, it means that those 4 digits must sum to less than 19, which means at most 18. And if you don't have such a symbol, it means that the sum is exactly 18. And for that reason, I will write 19 like this, but not in green. I will write it in, let's say, in blue, 19 like this. Yes. And I think 19 like this, yes. That's good. And this, so this, we have 19 like this, and I will write them all. So there's a sum of 19 here. This is a long process, I know, but I feel that it has to be done. So this is what is true for intersections of 4 cells. When it's on the border like this, the special number is no more 19, it's 9. So this must be more than 9, that is 10 or more. This is less than 9, so 8 or less, and this is 9. Oops. So I will put a 9 here, there, 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 and there, and there, and there. Oops, and I think this is not the right place to put the 9. I will put it rather here. Oops, what am I doing now? So here the sum is 9. This is about to be a long video, I'm afraid. 9 here, so that the sum here is 10. Let's just put it that way. The sum here is 10. And the sum here is 9. So that's the 9. Oh. So here, likewise, we get the sum of 9. And that's a sum of 10. Here, we get the sum of 9. That's a sum of 10. Here we get that sum of 9. And here we get that sum of 9. And I think, oh no, I forget this one again. That's a 9. That's a sum of 10. And that's a sum of 9. I can remove those 19s. Well, I hope I was right in removing the 19s. This 19 can be removed. This is 10. Well, now you can see this one. It means that this digit is more than 4, and this digit is less than 4. And the lack of symbol here means that the digit here is a real 4. Same there. So that this is 5, this is 5, and I will remove those numbers where they are not no more useful. All right, so that's the start. Now I must find the whole logic again, the logic that I did find earlier when I solved the puzzle for the first time. And as I told you, it might be a long video. But first, I'm seeing that here I've already got a sum of 36. The whole sum in the column is 45, so that this is 9. Right. Obviously, the sum is bigger than 9 here. There's no mystery about that. Now here I got a sum of 27 plus 13, that's 40, so this is a 5. The sum here is less than 9. So this is from 1 to 3. And this is from 6, 7, 8. The sum here is less than 9, so it's at most 8, so this can't be an 8. This can't be a 1, and this will be 1 or 2, and this will be 7 or 8. There again, the sum must be less than 8, so this is 7, this is 1, this is 8, that's a 2, and that's a 6, and that's a 3. I think this all works. And this is now 2, and I can remove those. They are fulfilled. So let's move on to this 19. We need another 12. Without using those digits, they must be 3 and 9. And to fulfill this clue, this has to be a 3, this has to be a 9, that's a 6, that's a 1. So those two must sum to at most 8. This is the reason for this 3. And here we need 4 and 7, but those 4 digits must sum to at most 18, and both of them work as it happens. This will be a 2 or a 5. I can remove this, this, and that. So that's a nice start. Well, do we go from here? Here, those 2 digits must sum to 11. They won't be 2 and 9, they won't be 5 and 6, they won't be 4 and 7, so they will be 3 and 8. That's 11. Those 2 digits must sum to at most 7. So they can still be 1, 4 or 1, 5. But the 1 is in here. Those are from 4, 5, and 9. 5 is not here. And we know that 9 is in here. So 8 is too big for this to be less than 19. So that's a 3, that's an 8. And by the way, this 19 here can be removed. And the 1 must be in here, otherwise we would have 21, which would be too big. Here we have 12, 4 and 5 both work. Here we need 11, so that 1 on this row can only be here. Note that Note that 9 on this row must be here. And this 9 told us as much. So those digits are from 4, 6, and 7. But here we have 15, so this has to be a 4. So this is 7, 4. What did I do? No, that's not a 4, that's a 6. That was not a 4-7 pair, that was a 6-7 pair. And here I need 7 to make this a total of 19, so that's a 6, that's a 7, and that's a 2. I think I fixed it. So this is now 2, 6, and 8 to satisfy all those conditions. Here we have 17, so both 4 and 5 work. Let's remove those partial sums. And let's see how we can move on from this point. So this 9 now can still be 1, 8 or 2, 7. This is less than 4, so it has to be 1 or 2. The other 1 or 2 is in here. The digit 9 must be somewhere in here. But 9 here wouldn't work because we would already have 16 plus at least 3. That would be more than 19. So 9 goes there. So here we have 1, 8 or 2, 7. The remaining 7 or 8 is here. So this is 14 or 15. So this can't be more than 4. Okay. Oh, none of those 9s here can use the 5 because 4 is in here. So 5 is somewhere in there. 5 doesn't work here. Have the 5 somewhere in here. And 9 also can't be in those. It can't be here. Can't be here. So that's a 9 and this is the 5. And 1 here would put an 8 there. That doesn't work. This is 7 with a 2. And this is 1 and 8. And that's a 7. So we have 14, 3 and 4 both work. Let's remove this 9 and this 9. So in here we have somewhere 3 and 6 and somewhere 1 and 8. That's not resolved yet. Here we need 3, 4, 5, 6. They sum to 18, which works perfectly fine. There's no 6 in here. And this is from 3, 4, 5. And those are from 3, 4, 5, and 8. Well, that's a lot of pencil marks, but I'm afraid it will be worth it. So here we need digits from 2, 3, 6, 7. Yes, I said 6, 7 again. This can't be 2 or 6, so this can't be 6 or 2. No, sorry, that's the opposite. It can't be from 3 or 7. Note that the sum of those two digits must be more than 9. It wouldn't work with the 2. So that's the 6 and that's the 3. Here this must be less than 9, so that's the 2, that's the 7. There's no 5 in here. This is 9. Those two digits must sum. Oh, I believe there's a 5 here. That's a 4, that's a 5. So here we need a sum of 12 without using the 3. It could be 5 and 4. It could be 4 and 8. 8, I said. Okay. I can remove this 9. I need a 9 somewhere on this row. It's not here. Could it be here? No. With a 9 here, the sum would be at least 19, which is prevented by this white dot. So 9 on this row must be here. 4, 7, so this is from 5, 8, and this is 4 and 7. Here we get 17, that works. Here we have 13. 5 wouldn't be enough. That's an 8. That's a 5. 5 I said, so that's 7 to get to 19, and that's a 4. Here we need 1, 2, 4, and 8. 4 is not in here. And this will never be 1 and 2, because then we would have a total of 16, which would not be enough. And actually, we need to be more than 19 here, so 1 doesn't work here. But my point is that 8 is in one of those two cells, so we can remove 8 from here. Those two digits must sum to 9, so 3 doesn't work. This 5 would need a 4, so 5 doesn't work. This is from 1 and 5. But 5 here would be too much. We would have 17, and this would be over 19. So this is 1. Here we have a 2, 4, 8 triple, so that this is 3. And we get here 9 and 5, so this is 9, this is 5. Here we need 2, 3, and 6, so this is 6, those are 2 and 3, and I can remove 2 from those cells. Down there we need 7, 8, 9, so this is 8 and this is 1. We need 7 and 9 here. This is from, well, it can only be 7 and 3. That's the 9. This is 4. This is 6, 5, 3, 4, 8, 5. So Sudoku does a lot there. 2, 4, 1, 8. That's a 2, that's a 3. That's a 4. Here I need 2 and 6, so 2 here, 6 there. Let's remove those. Oops, not those, but those on the border. This 19 puts a 1 in there. 8. So now I think I can finish just with Sudoku. So I will remove those. So those are 7 and 8. Alright, let's remove also this 19, and this 9. Here I need 1 and 9, and here 3, and here 6. And this is it. So it definitely helped that I already solved this puzzle. Otherwise, it would have been a very, very long video. But this solve was, I wouldn't say smooth, but the smoothest I could have made with such a mind-bending variant. And in the contest, Weiqi is the puzzle with the highest value. So I'm afraid it will be more difficult than that, much more difficult than that in the contest. But really, the very important point here is to look for the places where there is no symbol, because we know the exact value of the sum of the digits on those places. Thanks for watching this video. See you soon on SudoKanard.